Here we're going to look at topic 86, example 5, divide rational expressions. Before we get started, just notice that the numerator might have been switched from what you may have on your worksheet. So we're going to change the numerator to x squared plus 7x plus 6. So first thing I'm going to do is actually write this as a division problem. So x squared plus 7x, that's not at all what we wanted, plus 7x plus 6 over 1 minus x squared divided by x squared plus 5x plus 4 over x squared plus 3x minus 4. Hopefully the screen cooperates today. All right, so over here on the top right, I've listed 5 steps that we want to follow. They're very similar to what we did with multiplication. The main difference is that step 3, because we have division, we're going to look to multiply by reciprocal or copy, change, flip. And step 5, because we're going to be changing a numerator and denominator, we're going to need to recheck for our domain. Okay, so step 1, let's factor. The numerator, x squared plus 7x plus 6, I want factors of 6 that have a sum of 7. So 1 and 6, 2 and 3 are my options. 1 plus 6 is 7, so that works. So my numerator would be x plus 1 times x plus 6. My denominator, I have 1 minus x squared. I want to put that in standard form first, so I'm going to do negative x squared plus 1. Then I notice that my leading term is negative, so what we want to do is we want to factor that negative out. So we would do negative 1, which would be x squared minus 1. And now we have the difference of squares. So this would become, again, we can keep the numerator. My denominator, x squared minus 1 is the difference of squares, so that factors into x plus 1 times x minus 1. All right, a lot going on there, but we have the fully factored form. We're going to do the same thing with the fraction on the right. I'm going to keep this as division for now. So here I want factors of 4 that have a sum of 5. 1 and 4, 2 and 3, 1 and 4 check out. So let's use those. So this becomes x plus 1 times x plus 4. And my denominator, I need factors of negative 4 that have a sum of positive 3. So 1 and 4, 2 and 2, 1 and 4, something has to be negative. The 1 should be negative, so that gives me the positive 3 I'm looking for. So x minus 1 times x plus 4. Okay. So I'm going to just copy that step. I'm going to kind of cheat a little bit here. So that's just going to keep moving down. It's just going to make my life easier. So we're going to wind up here. I'll give you a second to copy that down. But we had a factor more on the left, so the right side we're just going to keep bringing along for the kind of the ride. All right. From here, we want to check our domain. Once you've fully factored the problem, you should look at your domain. So let's put that up top here. My domain is going to be all real numbers, except it's important you find the domain before you start canceling out and before you change this to a multiplication problem. You'll see why. My first group, x plus 1 here, that's going to give me a domain exception of x being equal to negative 1. Next group, x minus 1, that tells me that x cannot be equal to a positive 1. We have another x minus 1, which we've already taken care of, so we don't need to do that again. And then we have x plus 4, so that tells me that x cannot be equal to negative 4. So right now my limitations on my domain are negative 1, 1, and negative 4. Now that we've fully factored things and we've checked for our domain, the first two steps are out of the way, we can go on to the third step where we copy, change, and flip. So we're going to turn this into a multiplication problem. And this first fraction is going to stay the same. We're going to copy that. And then my second fraction, the division is going to turn into a multiplication problem. And my denominator is going to become the new numerator. And the numerator will become the new denominator. Remember, if you have something like 1/2 divided by, let's say, 3/10, that's the same as multiplying by 10/3, right? Instead of dividing, we multiply by the reciprocal. So we're applying that same concept just with a rational expression. So we copy, change, flip. Now you need to check for the domain again, because here we have a new set of binomials or pair groupings that are in our denominator. So there's potentially more exceptions to our domain. If we do take a look at this, the x plus 1 tells us that there can't be a -1, which we already have listed, and the x plus 4 tells us we cannot have -4, which we already have listed. So there's no new exceptions to our domain, but you do need to check because oftentimes there will be. Right? We have a new denominator, you need to check for your domain again. So the domain's been checked a second time, we're good because we can't do anything with that. Now from here, we're going to multiply and simplify. So I'm just going to write this to the right. I'm going to write everything out and then we'll look at canceling things. So remember, you can cancel on the previous step. I just don't want it to get a little cluttered. I want you to be able to see what we are doing. So I'm just copying the entire expression, multiplying it together. So I'm putting my numerators together and my denominators together. So things that we can cancel out. The x plus 1s can be eliminated. The x plus 6 has to stay. I have an x minus 1 that can be eliminated, and a group of x plus 4s that can be eliminated. So in my numerator, all I have left, I have x plus 6, -1, and x plus 1. So let's rewrite this as x plus 6 over -1 times x plus 1. Now, kind of officially, we're not done. We have simplified everything, but remember, if you have, let's say you have a fraction of 1/2, there's 3 ways to write this as a negative. You can say -1/2, -1 over 2, or 1 over -2. Right now, we're here. We want to write this with the negative in the numerator. So all I'm going to do is I'm going to take that -1. That negative can be moved to the numerator, and you can say -1 or just negative x plus 6 over x plus 1. All right, if you did stop here, I mean, you're not technically wrong, it's just not in your standard way of writing it. So you should try to always take a negative and just move it up into the numerator. The division problems are very similar to what we've done before in multiplication. The 2 things you're going to have to look out for, you'll have to copy, change, flip at some point, and you will have to make sure that you check for your domain because new numbers can be added to the domain. Right? Anytime something new gets put in a denominator, you're going to have exceptions that you have to look out for. All right, that's it for example 5. Hopefully by the end of these 5 examples, you have a pretty good understanding of what you're doing when you're multiplying and dividing rational expressions, and you realize that most of this ultimately comes down to being able to factor. If you can factor correctly, it's pretty easy to cancel or simplify groups and terms.